Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey students, welcome to physics, honors physics. Here with Mr. Bergman. Hey, what we want to do today is we're starting a unit on something called kinematics. We're going to be here for a long time, a number of months, and kinematics is the study of how things move. So we're talking about how things move, like kinesthetic is moving things. So how things move matters, and what we're going to do is we're going to learn about how that works. And today, or at least this short video, we want to talk about some key terms. So the key terms we want to start with is distance. I want to define these terms. Distance is a measure of distance, from one place to the other. You know distance. It's a dimension. Meters. You can measure meters or centimeters or miles or something like that. But then position, and then displacement. All right, it's best to just give examples. So if I have, and we're going to primarily work like with the XY plane, right? So if I have somebody who's here at the origin, and then they travel to here 3 meters away, their distance is 3 meters. Their position, now this is more important, their position is 3, 0, if you think about it. They've gone 3 meters in the X direction and 0 meters in the Y direction. And the displacement is 3 meters. They've gone, now displacement is how far from the origin, or from the original location. Now in this case, this is 3 meters and this is 3 meters. But let's take a second example. Let's say I have a coordinate plane, and then somebody goes and they travel to here to, let's call it 3, 2. So over 3 and up 2. Right, they've traveled in the X direction 3 meters and in the Y direction 2 meters. All right. Now if the person walks from here to here, they've traveled a distance of 5 meters, right? 3 plus 2. But their displacement is actually from the origin. It's the hypotenuse of this triangle. So and they use Pythagorean theorem. So their displacement is the square root of 3 squared plus 2 squared, which is, I calculated it out. Get your calculator out. That's 3.6 meters. And that's displacement. Now, and this leads us also to another important term, and that term is velocity. Now, let's say that the person traveled. So let's try another example, and I'll come back to this here in a minute, too. I've got my coordinate plane, and then somebody in a certain period of time, they go from here to here. They go 3 meters, but it takes them, let's say, 2 seconds. Okay, so that's their speed, if you will, versus, or their velocity. We'll talk about the difference between velocity and speed in a second. That's what we're getting to. Is they have traveled 3 meters in 2 seconds, or we can say 3 divided by 2, 1.5 meters per second. Okay, so that person has traveled 1.5 meters per second, and that is called their speed. Okay, but velocity is defined as the change in distance over time. Sometimes we'll say the change in x over time, and the delta sign means change in, but this is a vector. Now we're going to talk about vectors in the next video, but vectors are important because the velocity could also be 1.5, but the difference between velocity and speed is velocity has a direction. So you would say 1.5 meters per second to the east. Or sometimes you'll talk about angles and such like that. So the difference between this speed, it's just 1.5 meters per second, and velocity, we have a direction. So what you've learned about in vector land is that vectors have both a magnitude, a number, and a direction. They have to have both, where just speed or just distance have just a number. There's no direction. If I have a displacement, let's go back to this one, we can have a displacement vector. We can say 3.6 meters, and now what we have to do is say what the direction is. So we'd have to use some kind of trigonometry to figure out what that angle is, and whatever that is, the angle at x degrees. I don't know what that is. Actually, how would you do that? Let's just do it. It wouldn't hurt us to figure that out. What you do is SOHCAHTOA, right? And this is going to be opposite over adjacent. So I would say opposite over adjacent, that's tan. So I would say tan of theta equals 2 over 3. And then I would solve for that angle. By the way, to do that on your calculator, you're going to actually use the tan, sometimes called the arctan, but it's tan -1, parentheses, 3 divided by 2, and that will give you your angle. So you would say that this is 3.6 degrees, once you put that in the calculator, have it with me, at that degrees, and that would be your distance vector. Hey, physics students, we don't have a problem. So see you in class.